Hi class, so I am recording this video to be able to do lab number 3. And I am using this web-based application called Number Analytics. And what we're going to do today is run an independent t-test. So in lecture, I talk about a study where they wanted to compare the grades of high school students based on whether or not they watched Sesame Street as children. So the groups were split up into an independent t-test because we had one group of students who did not watch Sesame Street and a second group, a different group of students who watched Sesame Street. And so that's the definition of an independent t-test, was where you have two different groups, and you want to compare. There are two different individuals in two different groups. So I went to Number Analytics. I made an account, a free account with my LA Valley email address, and then so the data will be uploaded. So download the Excel version. It says here you can also upload SPSS files, but so you can try doing that. But I did it. I also uploaded it as Excel. And I called it, and it automatically was named Lab 3. So let's get started. So I'm just gonna make sure that my data uploaded correctly. And so so I compared pretty much from that example, I uploaded the data. So I put in the grade for the different groups, and then I numbered the groups. So one, which I didn't put in here, but one is the group that watched Sesame Street as children, and then 0 is did not watch Sesame Street as children. And then what I'm making sure is that each row is an observation or an individual's, I guess, grade. And so I'm just making sure that I have 20 rows. So I have 20 individuals, and 10 of them are in this first group, and 10 of them are in the second group. So how I'm going to get from here is I want to first look at summary statistics. So I'm just going to press summary statistics, this blue button, and it shows that, okay, I have 20 observations. I have 20 observations, so OBS is observations, and then it shows the mean for grade is 89, the median is 89, and standard deviation is 5.982, minimum grade is 79, maximum grade is 99. So this is the group variable, which is just where I noted if 1 was they watched Sesame Street as children and 0 is they did not. So it's just going through that statistic. What we're really interested in is what the grade is. So then I'm gonna go over to statistics. Oh, okay. So also copy this summary table, and then I opened up a Word document and I just saved it. So you copy it. So let me just start this over. Close this. So I'm gonna make a new Word document. And I am gonna paste, oops, that's weird. Sorry. So copy, why didn't paste? There it goes. Okay. And I'm gonna save this file so I don't lose all my stuff as lab 3 output. So I'll save it in lab 3. Okay. And then we're going to go to statistics. So what we're interested in is an independent t-test. So this is the same exact example that we went over in lecture. And you can see, let's compare what we get in this program compared to what we found in lecture. So this is just saying, okay, so I want to make sure that I'm looking at my own data, and it should be this data, right? So the grades data where it's split into groups. It doesn't show all the data, it just gives you a preview. So I'm going to say select because yours, which is mine, and you can change it as well. So I just want to make sure I'm in lab 3, my lab 3 data. So since it's already open, it knows. So let's go back to that. So independent samples t-test. I'm going to press select because this is the data. So the test variable is meaning what is your dependent variable? What's the outcome measure that you're trying to measure? So our outcome measure is grade as high school for high school students. And then the grouping variable is our independent variable. So we're trying to compare kids who watch Sesame Street as children versus the grade of students who watch Sesame Street as children. So I'm going to select group as my grouping variable. And then you press run. My internet's very slow. Okay, and then we see that we get t-value of 4 and a p-value of 0.001. And this is something you don't really have to know about, but when you're comparing two different groups with an independent t-test, because you take into account variance, right, into the equation for calculating the t-test, a lot of times you want the variance between the two different groups because we're comparing two independent groups. You want that variance to be very similar because if it's not, then there are some assumptions that are violated. So this is good. Our data is the variance between the two groups is good. And then we can see the means. So it's just comparing means between our 0 group is the group that did not watch Sesame Street as children, so that's their grade. And then the 1 group, which is the group that watched Sesame Street. And so we can copy this and paste it into our output. And then in advance, sorry, I went there really fast. This next tab, advance, is where there's more information. So what I'm really interested in is how big of a difference was it from group 1 versus group 0, right? So we see the mean for group 1 who watched Sesame Street is 93, and the mean for group 0 is 85, and that's actually a significant difference. So let's copy this table too. Right, because we found that t-value was 4 and the p-value is 0.001. Okay, save that so I don't lose it. And then there's this test for whether or not variances, as I mentioned earlier, that the variance between the two different groups, if it's actually violated. So this is where equal variances are assumed, and you don't want this to be significant. If it's significant, that means your assumption is violated. And then we see our t-test, and then remember we calculate degrees of freedom, right? So this sample size, so there's 10 in one group, 10 in the second group. So we know that degrees of freedom for group 1 is 9, right? Because degrees of freedom is the sample size minus 1. And degrees of freedom for group 2 is 10 minus 1 as well. So total degrees of freedom for this entire test is 18. Okay, because you add up degrees of freedom for group 1 plus degrees of freedom for group 2. The mean difference, so they say how big, so that would be 93 minus 85, which is 8. And then they calculate the standard error difference. And then I talked about confidence levels, intervals. So these are the confidence intervals for the mean difference. Okay, so did I copy that? Yes. No, I didn't. Okay. So let's also copy this table. And that is all you need for your write-up. Oh, I already copied it. Didn't paste very well though. I don't have the confidence intervals for some reason. Well, you don't actually need the confidence intervals, so this is okay. But it looks like I copied it. So just having these tables is fine. Okay. So that's all I expect for the output, but then you also need to write up your APA format, and all the information you need would be in this output.